Are there any questions from the audience or from people online? Maybe you can ask the question, I repeat it. Hang on. If it's too long, I can't repeat it. There you go.
This is for Ben. So I'm wondering, so a number of people are doing near field microscopy of samples. So does this emissivity issue also pertain to the near field?
I guess I don't fully understand what you mean by near field.
Okay, so the near field is you have an optical tip.
Oh,
And then they just look at really spatially localized mapping. But there is some data that I've seen where they see the Christensen feature move around as they sort of map the feature, and but the chemistry or the composition isn't changing. So could it be some
yeah, that's an interesting idea. So what I was talking about specifically here would require a temperature change to be driving the shift in the Christensen feature. So this is probably something different than that. But I would be interested in learning more about that.
Right.
Bernard Freund, Urban Mars, about the zero correlation of regolith depths with age. Whether you have also information about the change of the dispersion of the measurements with age. In particular, well, what is the statistics of area which has a very little thickness, because this could be very interesting. Then you could go to bedrocks and so on, and those that have a high amount of regolith thickness. So is there a case where this dispersion will be different as a function of age?
Yes, so one of definitely the regolith depth is highly variable. Is that what you're referring to? And so it could be that this range that I'm seeing is, has to do with the variability of the regolith, and perhaps certain areas tended to be, I think that might be part of it, that it might be hard to get a tight correlation because the regolith is so highly variable.
And then could you quantify, in fact, the distribution of regolith depth for a given site? And
So it seems that in general, when you do individual regolith depth measurements within one site, you get everything from extremely thin, basically down to the lower limit, up to, you get most of them group, I'd say within a couple meters, maybe 5 meters at the most. You get 50% of your data. And then you get a huge tail out toward the much higher depths, up to like 20 meters, and every once in a while, even up to 40 meters.
Just to follow up also on the regolith depth question is, have you considered whether that just reaches a steady state at some point, and how you might be able to model that?
Yes, so that's probably one of the things we're going to look into. I am wondering if, yes, the regolith has somehow, reached a steady state, and therefore it's no longer growing. But a lot of the older papers that studied the regolith back in the 60s, 70s, 80s, seem to think the regolith should still be increasing in depth. So if that's not true, maybe we can use new data to better understand what's going on with the regolith. But that is something to consider. But in the literature, that has not been what has been assumed.
Okay, thank you. I also have a question for Urs. So you've just been looking now at sort of the thermal situation, sort of for the mass wasting. Have you also started to look at maybe whether the craters that are in closer proximity to scarps have a different expression of mass wasting compared to ones that are farther away?
Yes, that's actually on our list of one of the next tasks, which we are looking now, where we have the results from the distributions, which patterns we see. So that's to come.
Oh, yeah. Quick question to Mark for noble gas analysis. What temperatures are we talking about that you require in order to do your isotope measurements?
So I knew someone was going to ask this. Within our system, we can't actually correlate the laser temperature, the laser power to temperature. We have tried it, but because the laser couples differently to, depending on really the color of the sample that you're hitting it with. So one of the things that we're hoping to do is to take our gas release curves and compare them to one from Finesse to see how their kind of much finer temperature control compares to our release curves. And hopefully through that, calibrate our temperature release.
Yeah, that's interesting. Could that not be modeled perhaps to correlate? I mean, thermal model through thermal modeling. Probably not common.
It probably could be done. It'd take a lot of work to do it. It's something we keep as a lab looking into and using pyrometers to try and get the temperature as well.
Okay, thanks. One last quick question. Yeah.
Just a follow-up question after Carolyn's. So like, to Gwen, it's like, how do you reconcile the size of the impactor? Because you mentioned in your previous slides, in the first ones, I think, that the size of the impactor is what defines. But as you know, time goes on, the more aged surface will have seen more of larger impacts. And as you go through the time, they become smaller and smaller. So you are essentially adding in number of impacts, but the size of that impactors are going through, like, becoming smaller and smaller.
So there is a production function for impactors that hit the lunar surface. And that's going to have a distribution from large craters, which there are very fewer of, down to smaller craters, which there are much more of. So over time, we believe that impactor distribution has been dropping. So we expect the rate of growth of the regolith to be going down, but it should still be increasing. There should still be large impactors hitting sometimes. So even though the rate at which the regolith is growing should be dropping, it should still be growing, even if it's growing more slowly.
Okay, I think that concludes this session. Let's thank the speakers again.